Rotate point C, negative 18, negative 20, 270 degrees clockwise about negative 1, negative 6. All right. So first, I'm going to identify the important parts. Our preimage is located at negative 18, negative 20, and our point of rotation is located at negative 1, negative 6. So one of the first things we should do when looking at this is we need to find the difference between the preimage and point of rotation to allow us to know that we find the difference to allow, which allows us to know where this preimage is located in relation to this point of rotation. In other words, we find the difference. It allows us to use the origin rules for rotations. So there's nothing real new. Okay, so I'm going to use this arbitrary letter M to represent the x value in relation to the point of rotation. So we have negative 18 minus negative 1. You get M is equal to negative 18 plus 1. You get negative 17. N represents the difference between the y values. Negative 20 minus negative 6. You get N is equal to negative 20 plus 6, negative 14. So you get the location of this point would be at negative 17, negative 14, assuming the point of rotation was at 0, 0. Okay. So let's just get some highlighting done. M negative 17. Then we have N is located at negative 14. And then another point that's important is negative 1 and negative 6. The reason why we need this is we need to add this to our answer at the end because it offsets the distance from the center. It acts like a makeshift center, basically. Okay, origin, I should say. So from here, we would typically do, if it was at the origin, x comma y, 270 clockwise would look like this, negative y, x. But now, what we have instead is we're going to be using these values. So we would have that right there, and we would have our y value plugged in there. Only difference now is we're going to plug in the point of rotation to add to both of these, okay? So our preimage, where we started, is negative 18, negative 20, and we're going to be rotating it, and it gets us to be at, what's that going to be? Negative 14 plus negative 1, comma, and then just the regular x, negative 17 plus negative 6. So all I plugged in here, just to keep everything kind of consistent, this negative 14 represents that n value. That negative 1 represents the point of rotation, so the distance from the origin. And then we have that negative 17, which represents the m value, the difference. Then we have negative 6. All right. And so right here, negative 14 becomes 14 plus negative 1. Well, that's going to give us a 13. Negative 17 minus 6 would give us negative 23. All right, so our C prime would be located at 13, negative 23.